Hey there, science explorers, welcome to our channel. I'm so excited you're here, ready to embark on a journey into the fascinating world of science with me, Hoss7M Gaming. You know, science isn't just about textbooks and labs, it's all around us, shaping the everyday experiences we often take for granted. In this video, we'll delve into the science behind some of these everyday phenomena, uncovering the amazing secrets that make our world so cool. We'll break down these complex phenomena into their fundamental elements, making it easy for you to understand how they occur. So buckle up, get ready to be amazed, and let's start our journey to uncover the science behind these incredible phenomena. Have you ever looked up at the sky on a clear, sunny day and wondered, why is it blue? Well, get ready to have your mind blown because the answer lies in a fascinating phenomenon called Rayleigh scattering. You see, sunlight, which appears white, is actually a mixture of all the colors of the rainbow. When sunlight enters the Earth's atmosphere, it collides with tiny particles of air, like nitrogen and oxygen molecules. Now here's the key. Blue light has a shorter wavelength than other colors in the spectrum. This means that blue light is scattered more easily by these air particles than other colors. Imagine the blue light bouncing off these particles like a pinball in a machine, scattering in all directions. This scattered blue light reaches our eyes from different parts of the sky, making the entire sky appear blue. It's like a beautiful blue canvas painted by scattered light. To really visualize this, imagine shining a flashlight through a bottle of water with a little bit of milk mixed in. The milk particles will scatter the light, and you'll notice that the light appears bluer as it passes through the mixture. That's Rayleigh scattering in action. So, the next time you gaze up at that azure expanse, remember that you're witnessing a spectacular light show orchestrated by the Earth's atmosphere and the amazing physics of light scattering. It's a beautiful reminder that science is everywhere, even in the simplest things we often take for granted. Rainbows, those mesmerizing arcs of color that grace the sky after a rain shower, captivating our hearts and imaginations. But have you ever wondered how these breathtaking displays of color are created? Well, prepare to be amazed by the science behind these ethereal beauties. A rainbow is formed through a magical combination of sunlight and water droplets in the atmosphere, resulting in a captivating dance of refraction, reflection, and dispersion of light. Imagine this: sunlight enters a raindrop. As light passes from air to water, it slows down and bends, a phenomenon known as refraction. This bending separates the white sunlight into its different wavelengths, or colors, just like a prism. Now, the separated colors travel to the back of the raindrop and bounce back or reflect off the inner surface. As the reflected light exits the raindrop, it undergoes another round of refraction, further separating the colors. This double refraction, combined with the reflection, creates the arc shape of the rainbow. The different colors are refracted at slightly different angles, with red light bending the least and violet light bending the most. This is why we see the familiar pattern of colors in a rainbow: red on the outer arc, followed by orange, yellow, green, blue, indigo, and violet on the inner arc. It's like nature's way of putting on a spectacular light show after a refreshing rain. You can even create your own mini rainbow at home. Just grab a glass of water, find a sunny spot, and hold the glass up to the light. You'll see a miniature rainbow dancing on the wall. It's a fun and easy way to witness the magic of light refraction and create your own dazzling display of colors. Chapter 3. The Science of Bubbles. Why these fragile wonders? Pop. Bubbles. Those delicate, shimmering spheres that bring joy and wonder to people of all ages. Whether you're blowing bubbles in the park or watching soapsuds dance in the sink, there's something undeniably captivating about these ephemeral creations. But have you ever stopped to ponder the science behind these fragile wonders? What makes them form, and why do they inevitably pop? Let's dive into the fascinating world of bubbles and uncover the secrets behind their fleeting beauty. At their core, bubbles are tiny pockets of air or gas trapped within a thin film of liquid, typically soap and water. The secret to their formation lies in the unique properties of soap molecules. Soap molecules have a hydrophilic head, which is attracted to water, and a hydrophobic tail, which repels water. When soap is added to water, these molecules arrange themselves on the surface with their hydrophilic heads pointing towards the water and their hydrophobic tails pointing away. This arrangement creates a stable structure that allows the soap film to stretch and form a thin, spherical membrane around a pocket of air. The surface tension of the water, which is the cohesive force that holds water molecules together, also plays a crucial role in bubble formation. Surface tension acts like an invisible skin, trying to minimize the surface area of the liquid. This is why bubbles form a spherical shape, as a sphere has the smallest surface area for a given volume. But alas, the beauty of bubbles is fleeting, and they are destined to pop. Several factors contribute to their demise. One of the main culprits is evaporation. The water in the soap film gradually evaporates into the surrounding air, thinning the film and making it more fragile. Dry air, wind, and even contact with dry surfaces can accelerate this evaporation process. Another factor that can cause bubbles to pop is contact with impurities or rough surfaces. These can disrupt the delicate balance of forces within the soap film, causing it to break apart. Think about how easily a bubble pops when it touches a sharp edge or a dusty surface. Chapter 4. Why does ice float on water? A matter of density. Have you ever noticed how ice cubes gracefully float on the surface of your drink, refusing to sink to the bottom? This seemingly simple observation actually reveals a fascinating scientific principle that plays a crucial role in our world. Density. Density is a measure of how much mass is packed into a given volume. In simpler terms, it tells us how tightly packed the molecules are within a substance. Water, in its liquid form, has a higher density than ice, meaning that the water molecules are more closely packed together. This might seem counterintuitive at first, as we usually associate solids with being denser than liquids. However, water is unique in this regard. The secret to ice's buoyancy lies in the way water molecules arrange themselves when they freeze. In liquid water, the molecules are constantly moving and forming temporary hydrogen bonds with each other. These bonds are relatively weak and break and reform frequently. However, when water freezes into ice, the molecules slow down and form a more stable crystalline structure. In this structure, the hydrogen bonds between water molecules become more rigid and form a hexagonal lattice. This lattice arrangement creates empty spaces between the water molecules, resulting in a lower density for ice compared to liquid water. Think of it like packing a suitcase. If you randomly throw clothes into the suitcase, they might not fit as efficiently, leaving gaps and wasted space. However, if you carefully fold and arrange the clothes, you can fit more into the same suitcase. Similarly, the ordered arrangement of water molecules in ice creates more empty space, making it less dense than liquid water. Because ice is less dense than water, it floats on the surface. This property has significant implications for aquatic life. If ice were to sink, lakes and ponds would freeze from the bottom up, trapping aquatic organisms in a layer of ice and making it difficult for them to survive. However, because ice floats, it forms an insulating layer on the surface, protecting the water below from freezing and allowing aquatic life to thrive. Chapter 5. How do magnets work? Unlocking the power of magnetism. Magnets, those mysterious objects that possess an invisible force, attracting certain metals and repelling others. From refrigerator magnets holding up our children's artwork to powerful magnets used in medical imaging and high-speed trains, magnetism plays a crucial role in our technological world. But have you ever wondered what gives magnets their seemingly magical powers? The answer lies in the fascinating world of atoms and the behavior of tiny particles called electrons. Every atom has electrons, which are negatively charged particles orbiting around the nucleus, which contains positively charged protons. These electrons are in constant motion, spinning on their axis like tiny tops. This spinning motion creates a tiny magnetic field around each electron. In most materials, the magnetic fields of individual electrons cancel each other out because the electrons are spinning randomly in different directions. However, in certain materials, such as iron, nickel, and cobalt, the electrons in neighboring atoms can align their spins. This alignment creates a much stronger magnetic field that extends beyond the individual atoms, giving the material its magnetic properties. This region of aligned electron spins is called a magnetic domain. Think of magnetic domains as tiny magnets within the material, each with a north and south pole. When a material is not magnetized, these domains are randomly oriented, and their magnetic fields cancel each other out. However, when you expose a magnetic material to an external magnetic field, such as from another magnet, the magnetic domains within the material can align themselves with the external field. This alignment strengthens the overall magnetic field of the material, turning it into a magnet itself. The strength of a magnet depends on how well the magnetic domains are aligned. Permanent magnets, like the ones on your refrigerator, have their domains permanently aligned, creating a constant magnetic field. Temporary magnets, on the other hand, lose their magnetism when the external magnetic field is removed and their domains return to a random orientation. Outro, that's a wrap. Keep exploring the science around you. Wow, what a journey through the wonders of everyday science. We've explored the secrets behind the blue sky, the magic of rainbows, the fragility of bubbles, the buoyancy of ice, and the invisible forces of magnets. From the vastness of the atmosphere to the intricate world of atoms, science is everywhere, shaping our world in fascinating ways. We hope you enjoyed learning about these everyday phenomena and gained a newfound appreciation for the science that surrounds us. Remember, curiosity is the key to unlocking the mysteries of the universe. So, keep asking questions, keep exploring, and never stop learning. If you liked the video, don't forget to subscribe to the channel and turn on the notification bell to catch more exciting scientific content. See you in the next video.